Welcome to General Chemistry 2 class. This section is on electrochemistry. This lesson is about redox reactions. Let's begin. In this lesson, we will define oxidation and reduction reactions. Electrochemistry is the branch of chemistry that deals with the interrelationship between chemical reactions and the electrical energy accompanying them. The chemical reactions studied in electrochemistry are oxidation-reduction reactions, or simply redox reactions. A redox reaction is a reaction that involves transfer of electrons. It consists of two half reactions, oxidation and reduction. Oxidation is a half reaction that involves losing of electrons, whereas reduction is a half reaction that involves gaining of electrons. The combustion of barium metal is a redox reaction. In writing the balance equation, we can write the product by separating it into ions. The conversion of barium metal to barium ion involves losing of electrons. This half reaction is called oxidation. On the other hand, the conversion of oxygen to oxide ion involves gaining electrons. This half reaction is called reduction. Note that oxidation and reduction occur hand in hand with each other. One half reaction will not occur if not for the other half reaction. One thing that is considered in determining whether a reaction is a redox reaction is by looking at atom's oxidation number. The oxidation number or oxidation state tells the number of electrons lost or gained by an atom in a molecule or ionic compound. Here are the rules in assigning oxidation numbers. Each atom in free elements bears a zero oxidation number. For a monoatomic ion, the oxidation number is equal to the charge of the ion. In the case of mercury 1 ion, the oxidation of each mercury atoms is positive 2. Divided by 2 or positive 1. In the examples given below, sodium ion has an oxidation number of positive 1, fluoride ion has negative 1, aluminum ion has positive 3, and sulfide ion has negative 2. Oxygen has an oxidation number of negative 2 in most compounds, except for oxygen fluoride, in which oxygen has an oxidation number of positive 2. In the case of peroxide ion, the oxidation number of each oxygen atom is negative 2 divided by 2 or negative 1. While for superoxide ion, each oxygen atom has an oxidation number of negative 1.5. For compounds with hydrogen, each hydrogen bonded to nonmetals has an oxidation number of positive 1. When bonded to metals to form binary compounds, hydrogen bears an oxidation number of negative 1. Fluorine in compounds has an oxidation number of negative 1. The other halogens chlorine, bromine, and iodine has an oxidation number of negative 1. When they are in the form of halides, when bonded in oxygen or a more electronegative atom, the oxidation numbers of chlorine, bromine, and iodine can be positive. For example, the oxidation number of chlorine in chlorine monofluoride is positive 1. In a compound, the sum of oxidation numbers of all atoms is 0. In a polyatomic ion, the sum of oxidation numbers of all atoms must be equal to the net charge of the ion. Consider sulfur trioxide, dichromate ion, and hydrogenium ion. For sulfur trioxide, the oxidation number of each of the three oxygens is negative 2. Let X be the oxidation number of sulfur. To find the value of X, the sum of the oxidation numbers must be 0, since sulfur trioxide is a neutral molecule. Solving for the oxidation number, we get a value of positive 6. As for the dichromate ion, each oxygen has an oxidation number of negative 2, and the sum of the oxidation numbers is negative 2. Letting X to be the oxidation number of each chromium, we have 2X plus 7 times negative 2 equals negative 2. Solving for X, we get X equals positive 6. This is the oxidation number of chromium in the ion. In the case of hydrogenium ion, hydrogen has an oxidation number of positive 1, and the sum of the oxidation number is positive 1. With this, we get the oxidation number of nitrogen, which is negative 2. Example number 1. What is the oxidation number of arsenic in arsenic acid? Solution. Let X be the oxidation number of arsenic in the molecule. The oxidation number of hydrogen is positive 1, while that of oxygen is negative 2. The overall charge is 0, since arsenic acid is a neutral molecule. Our working equation is 3 times positive 1 plus X plus 4 times negative 2 equals 0. Solving for X, we get X equals positive 5. Thus, the oxidation number of arsenic is positive 5. Example number 2. Assign oxidation numbers to all elements in ammonium phosphate. Solution. For ionic compounds, one good technique is assigning oxidation numbers is by separating them into ions. Afterwards, assign the oxidation numbers of the atoms for each ion. Be aware that the sum of oxidation numbers must be equal to the charge of the ion. Ammonium phosphate consists of ammonium and phosphate ions. For ammonium, given that each hydrogen has an oxidation number of positive 1, and the charge of the ion is positive 1, we can solve for the oxidation number of nitrogen, which is negative 3. For phosphate ion, each oxygen has an oxidation number of negative 2, and the charge of the ion is negative 3. Solving for the oxidation number of phosphorus, we get a value of positive 5. To know whether a reaction is considered a redox reaction, there must be atoms on the reactants that undergo change in oxidation number. Example 3. Determine whether each of the following reaction is redox. Solution. Write the oxidation numbers of all atoms shown in the equation. A. No atom among the reactants undergoes change in oxidation number. Thus, the reaction is not a redox reaction. B. Magnesium changes in oxidation number from 0 to positive 2. Oxidation changes in oxidation number from positive 1 to 0. Thus, the reaction is a redox reaction. C. Carbon changes in oxidation number from 0 to positive 4. Oxygen changes in oxidation number from 0 to negative 2. Thus, the reaction is a redox reaction. In terms of oxidation number changes, oxidation is accompanied by an increase in oxidation number, while reduction is accompanied by a decrease in oxidation number. An oxidizing agent is a reactant that causes oxidation. A reactant is the oxidizing agent when it is the one reduced in the reaction. In the given reaction of magnesium with hydrochloric acid, the latter reactant undergoes reduction as a result of electron gain in the hydrogen atom or decrease in hydrogen's oxidation number. Thus, hydrochloric acid is the oxidizing agent. A reducing agent is a reactant that causes reduction. A reactant is the reducing agent when it is the one oxidized in the reaction. Looking at the same reaction, magnesium is the oxidized reactant as a result of electron loss or increase in its oxidation number. Thus, it is the reducing agent. A mnemonic that wraps our discussion in the concept of redox reaction is Leora Cheroa, pronounced as Leora Cheroa. This memory aid means that a reactant that loses electrons undergoes oxidation, and this reactant is the reducing agent. On the other hand, a reactant that gains electrons undergoes reduction, and this reactant is the oxidizing agent. Redox reactions can be observed in the following reaction types. Combination, in which two or more reactants form a single product. Decomposition, in which a product is broken down into smaller molecules. Combustion, or the reaction of a compound with oxygen. And displacement, in which the ion or atom of a compound undergoes replacement with the atom or ion of a different element. There are two special types of redox reactions: disproportionation and comproportionation. Disproportionation is a redox reaction in which one reactant is oxidized and reduced at the same time. An example of disproportionation is the decomposition of hydrogen peroxide as an example. It oxidizes to oxygen, and at the same time, it is reduced to water. Comproportionation is the reverse of disproportionation. Oxidation of one reactant and reduction of another reactant yield the same product. In the given reaction, iodine is the oxidation product of potassium iodide and also the reduction product of potassium iodate. To summarize, an oxidation-reduction reaction is a chemical reaction that involves transfer of electrons, as tracked by changes in oxidation's number of atoms. Thank you. Welcome to the General Chemistry 2 class. This quiz is about redox reactions. Let's begin. Number 1. Number 2. Number 3. Four. Five. 6, 7, 8, 9, 10. Time's up.